Hello and welcome all. This is Educate Me and we are discussing the topic Wheel and Axle from the textbook of physics. First, we all need to know what is wheel and axle. The answer is it is a simple machine. Since we are on the topic of simple machine, that is chapter 1 of our physics textbook, first let us talk about the structure of it. First, we will talk about the structure of wheel and axle and then we will know its functions. First of all, it consists of the wheel and axle consists of the simple machine consists of two cylinders. The cylinder 1, this is the cylinder 1 and this is cylinder 2. Cylinder 1 is the one with larger radius and the other, that is cylinder 2, is with a smaller radius. So this is cylinder 1 and this is cylinder 2. Now what is radius? Since the cylinder 1 is in a circular shape, we will take the example of a circle to know what radius is. What radius is basically, it is the center of a circle. It is its circumference. The difference between the circumference till the center of a circle is called its radius, as you can see in the figure. Now what is the circumference? Circumference is the outer boundary of a circle. Now we know what radius is and what is cylinder 1 and what is cylinder 2. The name of the cylinder 1 is wheel and the name of the cylinder 2 is axle. Now we are coming to the third part. Third part is a shaft. Now here it is a shaft. It is a rotating machine element and is used to transmit power. It is usually in circular shape, as we can see in the diagram. It is in a circular shape. Now the shaft is done. We have the last part, that is a clamp, in which the shaft is gripped. The clamp is used to grip the shaft to allow it to move freely. Now what happens is, there is this rope, as we can see this point, a rope is wound round the cylinder 1, that is also called the wheel. Here at the end of the rope, effort is applied. Now effort, which is also denoted by capital P. Effort, what is effort? Effort is the amount of force that moves the wheel and turns the wheel through one revolution, that is a one complete round. And effort moves through a distance of 2 pi r. Means when the wheel is moving, the effort is moving and traveling a distance of 2 pi r. Now the axle also turns through one revolution, that is one complete round, and this happens simultaneously. Now the axle covers a distance of 2 pi r. To differentiate, we use a small r to represent the radius of axle, while a capital R to represent the radius of the wheel. So now we have 2 pi capital R for the wheel and 2 pi small r for the distance traveled through the axle. Thus, the time interval is same. Note here, the force of the friction needs to be negligible for the output and input to be equal. So now we come up to the numerical reasoning. Now we know the definition of output. With the definition of output is equals to W into P, where W is the load and P is the distance through which the load moves. We all know the distance is 2 pi small r for axle. Output and wheel through which we applied the effort is the input. For input, we know the formula P into D, where P is the effort and D is the distance through which the effort moves. Now output becomes equals to input, and we know the formulas of output, that is W into P, and the formulas of input, that is P into D. D is the distance and is denoted by 2 pi r. Now here we can see 2 pi capital R and 2 pi small r. W into 2 pi small r for output and P into 2 pi capital R for input. Now 2 cancels 2 and pi cancels. Now 2 cancels 2 and pi cancels pi. Capital R cannot cancel small r since both have different values. One has bigger radius while the other has a smaller radius. We all know that load upon effort, that is W upon P, is the formula of mechanical advantage. Hence, the answer is proved, that is mechanical advantage, which is also denoted by M dot A equals to capital R upon small r. We come to an end. Comment down your queries and see you next time.